So in this video, we'll be focusing on the equation of a line of y equals mx plus c, where we'll be finding the gradient and the y-intercept from a given equation, and also writing the equation when given the gradient and the y-intercept. Now, all straight lines, when plotted on a graph, will have an equation that follows a particular structure. Now, the equation of any straight line is going to be follows the format of y equals mx plus c. Now, the y and the x refer to the coordinates of what you would actually go on to plot, but the m, which is the amount of x that you've got, or how we mathematically say it's the coefficient of x, represents the gradient. Now, the gradient is basically the steepness of the line. Now, if m is positive, then the line will be going in an upwards direction. And if m is negative, then it'll be going in a downward direction. Now, the plus c is basically where the line crosses the y-axis, so we call it the y-intercept. So let's have a look at what we mean by each of these. So here we've got an example of 6 particular graphs. Now, in the first graph, we can see here that we've got a positive gradient because the line is going in an upwards direction. And the y-intercept is going to be this point here. So the y-intercept is also going to be positive. Now, in the second example here, we can see that again we've got a positive gradient because again the gradient is going upwards, but we can also see and note that the gradient in graph 1, if I just label these graphs, let's label that 1, 2, 3, 4, 5 and 6, you can see that the steepness in graph 1 is a lot bigger than the steepness in graph 2. So this in graph 1, that would have a larger gradient, a larger positive gradient I should say, than in graph 2. And the y-intercept is going to be here. So the y-intercept, and in this case, because it's below the x-axis, it's going to be negative. Now in graph 3, what I've got here is I'm going to have a negative gradient. And again, the reason for that is because the line is going downwards. And here, my y-intercept is here. And the y-intercept is also going to be negative because it's below the x-axis. Now in question 4, here what I've got is I've got 0 gradient because it's a flat line. So it's going to be 0 gradient because there is no steepness. It's just a flat base. It's just a flat surface. So it's 0 gradient, and the y-intercept is going to be positive. So we do have a y-intercept which is positive because it's above the x-axis. Now in graph 5, we can see here that we have no gradient. So there is a difference between having 0 gradient and having no gradient, because the steepness is, if you imagine you're falling off, rolling down a hill, this is a hill you do not want to fall down because there is no base. So here we've got no gradient, and we've also got no y-intercept because it doesn't cross the y-axis. And then finally for question 6, so again here we're going to have negative gradient because the line is going downwards, and the y-intercept is going to be positive. So we're going to have a positive y-intercept. Now what we're now going to do is going to match these to actually find out the value of the gradient and also find the value of the y-intercept. Now sometimes you may get asked to find the gradient and the y-intercept simply by looking at its equation. So you might not get a graph, and if you do get a graph, I'll do another video on how you can find the gradient and the y-intercept. Now there are some key notes that you need to be aware of, and obviously with it being a key note, let's just put a bubble around it. Now, if any of these keynotes make absolutely no sense to you at all, do not worry, because when I go through some examples, I will bring up these points just to reiterate them and just explain a little bit more detail as to what they mean. So for the key point for 1 is, before reading the gradient and the y-intercept from an equation, you must make sure that your equation has y the subject. Now, if you're not sure about what making y the subject is, it basically means y equals. So you don't want anything else, you want y by itself followed by an equal sign. Now there may be a time where you have got no y, and that's not going to be a problem. All it basically means is that it's just going to be a horizontal line. So let me just write that there. So if no y, then it's a vertical line. And it's just going to look something like that. Now, the next thing is that the gradient is the number in front of x. Now, the gradient can be negative, it can be a fraction. If there is no number in front of x, you can see an x, but there is no number in front of it, then the gradient is going to be 1. If you can see a negative x, then the gradient is going to be -1. And if there is no x, then the gradient is going to be 0. And then point 3 is that you may need to write the y-intercept as a coordinate. So again, just double check the question, and you might need to write the y-intercept as a coordinate. And again, I'll go through some examples of what I mean by that. And then finally, step 4, because you can have negative gradient and you can have negative y-intercepts, it's really, really important that you make yourself aware of any negative signs that are in front of the x or in front of the number that's either being added or subtracted, if there is one. So let's go into some examples. So in these particular questions, we've been asked to find the gradient and the y-intercept of the following equations. Now, from this, what we need to do is, now the gradient is basically the number in front of the x. Now, again, before we get started, we need to make sure that we've got y equals. Now, the first couple of questions, we've got y equals. So for that point, I don't need to do anything. But again, I'll go through an example where that is going to be the case, where you haven't got a y equals. Notably, for this question here, and some of our latter questions that we're going to do, which I'm just going to highlight now in terms of what we do with regards to those questions. So as it's y equals, all I need to do, the gradient is going to be the number of x's that I've got. Now in this case, it's going to be +2. Now if you want to write just 2, then that's absolutely fine. Then you can write just 2, but I'm going to write +2 just to show it's got positive gradient. Now the y-intercept is basically what number is being added or subtracted, and in this case it's going to be +3. And then writing it as a coordinate, well, it's always going to be 0, and then it's going to be whatever number is in this y-intercept column. So here I've got +3, so basically the coordinate is going to be 0, 3. Now moving on to the second one. So again, I'm looking at the gradient is what number is in front of the x. So here it's going to be +5. The y-intercept, well, there is no number being added or subtracted, so it's just going to be 0. And then writing that as a coordinate, it's going to be 0. And then whatever number is in this column here, so it's going to be 0, 0. Then moving on to this third question. So again, here the gradient is going to be -6. And again, I'm not adding or subtracting anything, so it's going to be 0. And then the y-intercept is just going to be 0, 0. Now, the key thing to remember is that this x-ordinate is going to be 0 for everything. So that's why in the previous example, it's just 0 and then c. So this is my c and this is my m. So then moving on to the next question. So here we've got no gradient because we're not adding any x. There is no x, so the gradient is 0. The y-intercept is going to be 6, so the coordinate therefore is going to be 0, 6. With the fifth question here, so here we can see we've got no gradient, so we could just write NA, or we say that there is no gradient. Or NA, not applicable. And the y-intercept is not going to be applicable, so there is no y-intercept, so no y-intercept. And then moving on to question, the next one, I should really number these questions. So for this next one, you can see now again, just be wary of the order in which it's written. So don't just automatically think that the gradient is the first number that you can see. Remember that the gradient is the number of x's that you can see. Now this plus belongs to 6, so the gradient is going to be +6. And the y-intercept is what number is being added or subtracted. Now, although there's not a symbol in front, if there is no symbol, it's just going to be positive, so it's going to be 2. So then the y-intercept is, as a coordinate, is going to be 0, 2. For the next question, so again here, I'm looking at how many x's can I see? Well, here I've got -2. Now, what you don't want to do, and what a lot of students tend to write, is -2x. It's not that. There's no x in the gradient, so make sure that you're just writing just the number, or like I said, just the coefficient of x, so just the number in front. And then the y-intercept is the number that's by itself, and again, so it's going to be positive 10. So therefore, writing that as a coordinate is going to be 0, 10. And there you go. For the next one, we can see that we've got no number in front of the x, so we're just going to assume that it's 1. We're not assuming it actually is. And we're not adding or subtracting anything, so it's just 0. And then so the coordinate is therefore going to be 0, 0. Then for the next one, here again, we've got minus 5x. So it's going to be minus 5. And the number being added or subtracted is minus 3. So we write minus 3 there. And then writing that as a coordinate, it's going to be 0, minus 3. Now moving on to the next one. So you can see here now we've got a fraction, which is again not a problem. So here we've got positive of a half, or just a half. And again, the number being added or subtracted is plus 7. So I've got positive 7. So therefore, writing that as a coordinate is going to be 0, 7. Then for the next one, again, we've got a fraction. So here we've got 3/4. So it's going to be 3/4. My y-intercept is going to be the number being added or subtracted, which is minus 5. And writing that as a coordinate is minus 5. Now, a question I usually get asked is, do I need to write the y-intercept as a coordinate, or can I just write down a number? Now, in a question, it will usually specify how they want you to write the y-intercept, but if there's no mention of it, or in a particular way, then writing an either or should get you the full marks. Then moving on to the next one. So again, need to be careful because again, the gradient is the number of x's, not just the first number. So here it's going to be minus 3/4. And the y-intercept, pretty big one, which is 22. So therefore, writing that as a coordinate is going to be 0, 22. Now, moving on to the next one. Now, when we've got 7x over 2, now 7x over 2 is the same as 7 over 2x. It's just a different way of writing things. So here, that my gradient is going to be just that fraction. So just ignore the fact that the x is on the fraction. So here the gradient is going to be 7 over 2 and the y-intercept is going to be positive 7. So then it's going to be 0, 7. And then moving on to this one here. So here I've got y equals 5x minus 3, all divided by 4. Now, how you want to write this, if you do have a question that looks like this, is basically split the fraction into two fractions. So I've got 5x over 4 minus 3 over 4. And then I can write that as 5 over 4x minus 3/4. So from this, I've got that my gradient is going to be 5 over 4. And my y-intercept is going to be minus 3/4. Now, would you then go on to convert that into a decimal? No, I'd leave it as a fraction. So I'm just going to have 0 minus 3 over 4, and there is the value as a coordinate. Now, as we mentioned before, that we need to make y the subject when it comes to finding out the gradient or the y-intercept from an equation of a line. Now, this tends to be a more high level and more tricky questions, but again, the format is exactly the same. So if I just quickly just number these, so 1, 2, 3, 4, 5, and 6. So looking at equation 1, let's just move it up a bit. So here we've got 2y equals 6x plus 3. Now, as I said, what you want to do is just get y by itself. You want y equals. You don't want 2y, you want y equals. So I need to get rid of this 2. So you ask yourself, how do I get rid of that 2? Well, what's the 2 doing? It's multiplying. So to get rid of that 2, what I need to do is divide by 2. So take it to the side and do the opposite. So here what I'm going to end up with is y equals, and 6 divided by 2 is 3x, and 3 divided by 2. Now, if you can't work it out, just leave it as a fraction. There's no harm in doing that. Try not to stress your brain of trying to convert it. Just leave it as a fraction. So from this, now I've got y equals, I can now read off what the gradient's going to be and what the y-intercept's going to be. So here the gradient is going to be 3, and the y-intercept is going to be positive 3 over 2, because then that's going to be, let's get a different colour. That's going to be this here, so it's going to be plus 3 over 2. So therefore, writing that as a coordinate is just going to be 0 and then 3/2. Now you could do it by sight. You don't have to do this. If you can recognize, right, okay, I need to get rid of that 2. So half of 6 is 3. Half of 3 is 3/2. Or if you wanted to write it as 1.5, then that's absolutely fine. That shouldn't be a problem. But I would say leave it as a fraction. It's easier. Now with question 2, so here I've got y plus 7 equals x. Now again, I haven't got y by itself, so I need to get rid of this plus 7. So ask yourself, what's the opposite of adding 7? Well, taking away 7. So then what I've got then is y equals x minus 7. And now I've got y equals, and now I can read off the information that I need to work out what the gradient is. Now the gradient is going to be, well, I've got 1x, so the gradient is going to be 1. And the y-intercept is going to be minus 7. So then the coordinate is going to be 0, minus 7, and there we go. For question 3, we've got y minus x equals 10. So again, I want to get y by itself, so I need to get rid of the x. How do I do that? Well, when you're subtracting x to get rid of it, you need to add x. So what I end up with is 10 plus x. Now again, be mindful of how this is written. So again, I've got 1x, so that means that the gradient is going to be 1, or positive 1 I should say, and the y-intercept is going to be positive 10, giving me a coordinate of 0, 10. And then moving on to question 4, so let me just create a bit of space. So let's just get rid of all of this. So then moving on to question 4 in this, so we've got 2y plus 8 equals x. Now again, what you want to try and do is get x by itself, or y by itself rather. So I need to get rid of this plus 8 first. So I do that by taking away 8. So I've got 2y equals x minus 8. Then I need to get rid of this 2. How do I do that? Well, I divide everything by 2. So y equals x divided by 2 and 8 divided by 2, which is 4. Now, when you've got something that looks like this, again, that is exactly the same as a half x. You can just move the x to the side and then it's just 1x. So here the gradient is going to be a half and the y-intercept is going to be minus 4. So then it's going to be 0, minus 4 as a coordinate. Now moving on to question 5, this one's a little bit more sort of demanding. So here we've got 3y plus 6x plus 10 equals 0. So again, the first thing I want to do is get rid of the 10. So I've got 3y plus 6x equals minus 10. Then I get rid of the 6x, which is adding. So I've got 3y equals minus 10 minus 6x. And I'm going to divide everything by 3. If I just move the screen up a little bit so we have a bit more space. So from this, what I've then got is y equals minus 10 over 3 minus 6 over 3, which is 2, so it's 2x. So from this, I can see that the gradient is going to be minus 2, and the y-intercept is going to be minus 10 over 3, giving me a coordinate of 0, minus 10 over 3. And then finally, for question 6, so what I've got here is I've got y over 2 plus 5 equals x minus 1. Now these are quite challenging questions, so if you were understanding the first set of questions and not so much the next ones, depending on what level you're working at, you may not even need to look at this. So I would say the first 8 questions are probably the ones that are most likely to come up. So looking at the next one, I want to get rid of this plus 5, so I do that by taking away 5. So what I've got is I've got y over 2 equals x minus 6. And then I need to get rid of this divide by 2. How do I do that? Well, I multiply everything by 2, giving me y equals 2x minus 12. So from this, I've got a gradient of 2, and I've got a y-intercept of minus 12, giving me a coordinate of 0, minus 12. And there is my final answer. Now, another type of question you could get is working in the opposite direction. So we may get asked to write down the equation of a line when you're given the gradient and you're given the y-intercept. Now, what you need to remember is the basic format. So we're dealing with y equals, let's write this in different colors. We've got m plus, or mx, I should say. And then we've got Let's go for pink. So we've got plus, actually let's use a different colour, let's go for yellow. So we've got mx plus c, and this is my c value. So all I'm going to do is I'm going to write down this equation, but I'm going to swap m for whatever number is in this column, and I'm going to swap my plus c for whatever number is in this column. So writing on the equation here, I've got y equals m, which is 4, and you're always going to have an x, and it's going to be plus 5, because again that's positive 5. For the next one, I'm going to have y equals m, which is 6, x, and then c, which is minus 2. For question 7, now with question 7 the y-intercept is written as a coordinate, but it's just this number that I'm after. So I've got y equals m, which is minus 7, x, and it's going to be positive 3. For the second question, well, for this one here, I've got y equals minus 3, because that's what m is, x, and then the y-intercept is going to be minus 4, so it's minus 4. For the next one, we've got y equals 1x, and then plus 0. Now we can also write this as y equals x, and that there is the final answer. But again, if you wrote it like this, you should still get full marks in the exam. For the next one, we've got y equals m, which is 9, x, and then we've got c, which is minus 8. The next one here, we've got fractions. Again, doesn't really matter. So I've got y equals m, which is a half, and I've got x, and I've got 3/8, and it's positive, so it's plus 3/8. For the next one, I've got y equals minus 3/4, x, and then it's minus 4. And then for the next one, I've got y equals 7x minus 1/4. And then for the next one, I've got y equals 0x plus 6. Now that there, I can write that as anything times 0 is just nothing, so it disappears. So I can write this equation as y equals 6. And then finally, now you can have decimals, but again, it's quite rare that you have decimals in these types of questions. So for this, if you were to, nothing really changes. So m is 2.6, so it's 2.6x, and then just add or subtract whatever number this is. So here it's going to be minus 8.5, and there is my final answer. Now I will put some practice questions on a worksheet in the description below, along with their answers for you to check to make sure you're getting this right. And like I said, this kind of follows on from either if you've already looked at finding the equation of a line from a graph, or that will be the next stage, in which I'll do another video on how to find the equation of a line based on looking at a graph.